Yo, what up? Yeah, I know I did it. I know. Yeah, the thing is whenever I start a stream, I have to spend like 10 minutes setting up things. So I made a countdown. And I did spend every second of that just being like, is this working? Do I know what I'm doing? So, yes, a little bit of an upgrade, a little bit of an upgrade. That song is also one of my AI music creations. It's all right. Yeah. It's meh. It's probably like slightly cringy. You know how like when you're in GarageBand or whatever when you're young, everything seems super cool. Like, you're like, "Whoa, I just made this sick beat." I'm still in that stage. I haven't like realized that everything is cringe yet. Um anyway, we're going to be unboxing keyboard version 2 today. So I've actually been sitting on this for like 4 days, but was very distracted because we ordered 3 boards, 2 of which are coming. But I was very distracted because I was trying to fix those boards, and we'll see. Publish to Spotify a few cents. Yeah, maybe. Uh, Little beats. Nah, I think I don't know. It's pretty hard to compete. It's pretty hard to compete. I also think AI music is getting pretty good. So, what cherry keycaps, sir? I do have some cherry keycaps. Yo, Bop, what up? What up? Oh my gosh, everybody's here. We're ready to go. We're ready to go. So we're unboxing the second custom keyboard today. As a reminder, there are 3 parts to a key. There is the hot switch. This isn't present on every keyboard. There's the shaft, which looks like this, keycap, and then a finished keyboard actually looks like this. It just has a bunch of switches. Yes, for people who were here last time, it didn't fit. It didn't fit. I'm not if this was a TV show, we would like flash back to that briefly, and it would be like grayscale, and it would be like, oh, it doesn't fit. But yeah, no, it didn't fit. We're not gonna relive it. Um, oh, there's also diodes. I forgot to place the diodes last time, so I'm hoping I fix things. But I do these super even though like I made mistakes or whatever, I still do these super fast. So hopefully it all works out. Okay, something I didn't have time to test was my lab desk setup. Let's see. Cool. I like frantically was moving things from my desk because I always have like random stuff that should not be on stream, like a passport or something, some bills. Okay, that's pretty good. I also have a second camera. Let me see. Last time I was doing this got pretty messed up. Oh. Didn't plug this one in. Oh, you know what? I don't have enough plugs from my we'll see how this goes. We'll start with this, and then we'll see how it goes. So, yeah, there we go. Okay, keyboard box. Let's do it. Yeah, my goal is to make 1 circuit a day so that I can do 1 unboxing a day. But because of the shipment time, it's always going to be 2 weeks from the design to the actual viewing of it. Very cool. All right. So, this is a 9-key keyboard. This is essentially like a mini numpad. And that's just because we want to make sure we're able to do stuff. And then we'll make a full-scale keyboard. But, full-scale keyboard, more expensive, of course. So you don't want to start with that if you're still just figuring out if your auto routing works and stuff like that. These are the unassembled boards. So what I do is they have a minimum quantity of 5 that you have to order. Did I do the PCB? Yes, we did the PCB with TS Circuit. And actually, I think TS Circuit will be the easiest way to do PCBs for custom keyboards in the near future. Okay, this looks pretty good. So I'm gonna show this on camera, and I actually have a special stand for this. So let me take a second to get it set up. I'll hold it up for a minute, but you can see the switches look pretty good on there, and we have the diodes populated this time. So the diodes are these little black bits. So the diodes are actually on there. So far so good. Yeah. I think I have all the tools to do this. All right. So we're gonna do a couple things. The main microcontroller, which is kind of like these silver parts here. Oh man, this is tough. I need my low camera. This main microcontroller isn't soldered on. They will not place this, which is actually one of the main reasons I think TS circuits kind of has to exist, is because you can't, like, a lot of people sell modules and they're like, oh, just solder on the module, but that's actually like quite a bit of effort to solder on a module. Just the fact that you have to do any soldering, right? So hopefully with TS Circuit eventually that would just be a React component that you could drop in and everything on that module would be populated. So I'm going to try to get a low camera going here. Let's see. I just need to figure out which one of these I can unplug. Oh, this one. Oh, easy. Okay. So we're going to get a third camera here so that I can have a zoomed in camera. Let's see. Okay. Let's go here. We're getting there. It's a process. Is that it? Oh. Oh. Oh man. OBS is struggling. Come on. You can do it, buddy. Oof. Oof. I want my second camera though, so I'm gonna mess around. I'll turn on face cam. Oh, I can't. Never mind. I gotta mess with it real time. Let's see. Remove. Add video device. See, this is what I should have been doing during countdown, but it's the way it goes. What can you do? What can you do? All right, is this the second camera? Does this look different than the other camera? The same. Yeah, this is the second camera. Cool. So let's just move that to the bottom. There we go. All right. Lots of views. Hopefully that's not too confusing, but this one is going to be my more portable camera, assuming it stays on. The PCB vise, which I'm going to use to hold the camera. I do have to remember how I did this before. Oh, maybe I did it like this. Ah, okay. I don't know. That's 50-50 stable, but I'm gonna go for it. All right, now I have a little something. So yeah, this is the close up of it. Let's go ahead and try to put a key in. Yeah. All right. So I've got a big bag of keys, key switches, key shafts, I like to call them. A lot of people would just say this is the entire thing because sometimes it is, but let's see if we can shove one of these guys in. So it goes on the top of the board. It's supposed to be a little bit hard to shove in there. Am I doing this right? one of the pins is getting bent right now, so, but it does go in. There we go. Yeah, okay. Cool. Kind of anticlimactic, but yeah. Switch goes into hole. So let's put a couple of these in. Last time the stream only lasted 10 minutes because it didn't fit in. Good enough? I hope so, because I am, there's limited amount of effort I can do here. All right, last time the stream ended after 10 minutes, and I thought I was going to waste a bunch of time putting in key switches, but since the key switches fit, I might as well waste the time putting it in. Then we're going to do continuity testing. So we're going to take some probes and make sure that when we like, pins connect, essentially when you press the button. I think I can do that continuity testing. It might get a little bit weird because there's a diode. So I might have to do some math to figure out how possible continuity testing is, but it's pretty good. Actually, yeah, maybe we can figure out how to do it with just one, because now that I think about it, I'm gonna have to solder the Pico on. I wonder if can I solder after I put the key switches on? Also, is this upside down? Just realized. Hold on. Keycaps have like an orientation, I think. I'm trying to figure out if it only goes in one way. I think it can go in multiple ways. I think you can put a keycap in backwards. So the ideal orientation is like, I guess, this way. Oh, yeah. Okay. That seems fine. There's not really an upright. There's that clicky sound. Okay. We don't want keycaps on, though. Ooh, that kind of pops out pretty easy, too. I guess you don't really tug on keys on a keyboard, though. Yeah, you can see the pin is getting a little bent there, but I'm pretty sure I used, like... Yeah, now it slides in really easy, so I don't know about that. I'm not quite sure what's going on there, but... Seems good. I'm really curious if I can do, like, a basic continuity test. So the code for this keyboard, by the way, if you go to snippets.tscircuit.com and you just search keyboard, just kind of up there and available. So what I want to know, I should have a full screen button. It's a good issue. Yeah, some pretty interesting little things. I'm gonna show some things on the scope if I can, because there are some like little interesting kind of mistakes that the TS Circuit Auto Router make. It won't break the board, and I knew that, so it's totally fine. I knew they were gonna come like this. It's just kind of interesting that JLC is able to do it. So I'm gonna use the microscope. Like, what I'm thinking of is this is like, there's a ton of vias in pad right here. So what does that actually look like when that comes in, right? And then I put in this bottom right, I guess. There was no silkscreen. Silkscreen wasn't implemented on TS Circuit when I ordered this. So I'm trying to figure out what orientation this is. Oh, this is how I put this in. There we go. This will be much more stable. I gotta lock it in, though. There we go. Do I have a meter? A multimeter? I should have a multimeter, but I actually have to unbox it because this basically everything I use is new now. Yeah. Okay, this is a lot more stable now. So we might be able to see on camera these little holes inside of the pads in the top left there. It's kind of interesting. Yeah, I guess I'll unbox the multimeter. I think I have to. Because, like, but I actually don't know what to test for continuity yet. First, I'm trying to do a couple things at once here. Okay, so the first is the orientation of the board. Based on the traces, this is the correct orientation. So this side is up. How are you going to measure the continuity? Definitely with the multimeter. Okay, so you want me to get the multimeter. All right. Order of operations, very important, I suppose. You just know that in my disorganization, I might not actually have it. And so you're like, oh, I should make sure he has it. Otherwise, you know, maybe he'll end the stream. If you don't have the meter, you can't even measure. Yeah, I got it. You know what, though? I don't know if it has batteries. Might have to go back to my countdown. I need a break countdown, actually. I think that might even be more important than the stream countdown. It comes with batteries. Measuring continuity, very, very easy. The problem is I do have a diode as part of the circuit, so I'm like a little bit like, will that work? Because how it works is it sends a small electrical signal, and I don't know if that works across diodes, but we can actually test by doing it over one of the diodes. So I used it for something once. Yeah, continuity makes sense even for like household use, because you can turn off your breakers and then you can see how switches are connected. Okay, so yeah, all right. So one-on-one on a multimeter. Yeah, this is a multimeter. So I have it set to continuity down here, which means if I touch these together, it beeps. I don't know if you can hear that. Sound's coming from here, so. Very basic. So what we want to do is have a configuration such that I can have these probes on the keyboard and then press the button and have it turn on. We did on the desk too. I don't know what that's in reference to. So like the easiest test of continuity here is we have, this might actually work. So we have this key switch. This would be really bad if this made a sound. We don't want these two to make a sound because that would mean the button is always pressed. Oh, wait. Or it, as long as it changes when the button goes down. So if I push it, it's on. It's kind of hard to tell what I'm doing. Actually, you guys have a pretty good view. So when I put the board down, these are going. But that's just a button. That's just how a button works, right? What we want to know is when it goes to these pads that it works properly. Yeah. Honestly, if you really, really wanted a great testing fixture, what you would do, maybe I'll do this in the future, but you would hook this up to an oscilloscope, a multi-pin oscilloscope, and then you would like press them and you would have a bunch of graphs that show each like button or signal or whatever. That would be ideal, but you know, laziness. So at some point you just got to trust the PCB. Or, you know, just start writing code. Okay, so I am curious about this diode thing because I've never thought about that for more than a second. So let's see across a diode if continuity works. We're going to have to flip it both ways. Okay, so this way is nothing. By the way, there's such a small amount of current, maybe voltage. I'm not sure about voltage, but there's such a small amount that you can't really damage anything. Yeah, so across a diode, it doesn't work. It actually, if I look at the multimeter, I'm going to switch these probes again. Yeah, okay. So the direction matters, which makes sense for a diode. But if I look at the multimeter as I connect these, can actually see 0.6-ish there. And that's pretty interesting. Buttons do foul. That's true. I guess it's good to test the button. These are cheap as I could get. But that 0.6 is suspiciously close to the voltage drop across a diode. So it's possible that, I mean, it does have a diode symbol on here. So maybe it is actually good enough to measure that. So that's where my multimeter knowledge ends. But that is useful that we know if a diode's in a way. Okay, so unfortunately, TS circuit, this is actually something I'm probably maybe going to do today if Rashab doesn't beat me to it. But we don't have a schematic view, so we kind of got to stare at the PCB or the code to figure out how these traces connect together in order to sort of run our test. Either that, or I could go right to the Pico being on this to get the Pico. All right, let's get our ducks in order. What's gonna happen? How do we make this a real keyboard? So obviously I could put all these keys on. I'm maybe gonna do that in a second, but I actually have to solder this microcontroller on, and that's the last big thing we have to test. So how that works, pulling out yet another box. This is actually a very good test to run. So when I originally ordered this, I put on a I don't know, some Arduino, but I was like, you know what? I don't want to use Arduino. I want to use Raspberry Pi stuff. I want to use the Pico. So this is the Pico. I forget what chip is on here, but I think it's yeah, I think I might have gotten this. Is that readable? What does that say? I have to pull that under the microscope here. See if we can adjust this live. Pico 2, but we want the chip. Let's see what the chip is. Probably better to look this up online. Yeah, I don't know about that. Yo, Rashab, what up? Spet PV, what up? Pico seems like overkill. Yes, Pico is overkill, but honestly, like, you know, the RP 2350 is what I really want to test. I don't know if this runs an RP 2350 though. Oh yeah, no, this is an RP 2350. So after we use the Pico, what we're gonna do is make a board with just that chip, the RP 2350, the black thing, and that'll be the first keyboard powered by RP 2350. But I also just think RP 2350 is going to be such a big chip in a couple of years because everybody is lauding it. So I think it's just a good platform to build on. It's just my hot take. So this footprint was created by somebody in the community. I'm trying to remember. Was it a NAS or was it? I think it was a NAS. Spet PV asks, what is this project about? We're building keyboards with React, with TypeScript and React. So we designed this custom keyboard that's slowly coming together. You got the Flux. I can't solder on camera because so I had this option in San Francisco. A lab is very expensive, and I was gonna buy a lab for live streaming, which I'm sure everybody would have loved, but my budget would have been destroyed. So it's all a matter of timing. Please solder on stream. Please, we must see. This is gonna be the most boring solder job in the world, by the way, because I'm not like, honestly, this one I would consider doing in this room. I won't because, you know, my girlfriend will be like, there's lead in this room, but basically, I'm gonna put solder paste on the pads, which I do with a push thing. I don't know if maybe I'll record a video of that, but you know, it's not going to be that interesting. Basically, I put a bunch of paste on these pads, and then I literally put it on a hot plate, which is going to be difficult because there's stuff on the bottom. But I'll try to like half put it over a hot plate. It'll get hot, and the Pico will just go in there. Did you get leaded solder? I think so. I think I was very lazy. I also did get a bunch of flux, so I have the full thing. Um. Uh. Yeah. I'm kind of intrigued. Uh. Everything seems to be going. Everything seems to look good. Like the lineup on that stamp seems correct. That was a major concern. This is the first time we've done a stamp, so I think it was a Nas. Great job on the stamp. Wouldn't be here without you. Or it's possible actually this isn't your stamp. Now that I think about it, I think this isn't your stamp. Never mind. But I can't wait to use your stamp next time. Now we know this one works at least. I think I had to hack this one together, and that's why the separation between these pads is pretty small. It's going to be easily bridged. Luckily I have a microscope to do some inspection of that. Is it solder time? Let me think. Continuity test. I want to see if I'm able to do a continuity test, and then I'll solder and I'll come back and we'll program the Pico. By the way, I've never programmed a Pico. In fact, it's been a long time since I've programmed a microcontroller. It's a little cringe, but I did it in the past. I did STM32s, I did Arduinos, I did basically everything. Is this having some hole issues, or will this be our first successful keyboard? So far, nothing is wrong. We're looking at the one thing I want to do is a continuity test, and then we'll know if it connects to the microcontroller properly. But honestly, the continuity test is a little bit tricky to do. I don't have enough hands for it, so I might just assume it's correct and kind of go for it. Right? We don't have a schematic, so it's really hard to figure out exactly what's going on. But yeah, I might just go for it. I have a little lab space where I can solder the Pico on. So yeah, because I'm trying to think of how I can do this continuity. I know it's behind my head, but I'm looking at how the wires are highlighted when I hover over them, and I'm like, okay, so I could do a continuity test from this point to whatever this connects to. Oh, wait a second. Why does this says 5 errors up here? Maybe and the errors are not routed connections. I wonder if hold on. Why does it have unrouted? I think we maybe an update to the auto router made it so these didn't route. I don't think I would have ordered a board that wasn't fully routed. But the traces do look identical. Did I order a board that wasn't fully routed? I'm still going to assemble it either way. I think I'm very like speed oriented. So what I might have done is I might have ordered it and said like, oh, well, let's just make sure the keys switch. But even though the traces look basically the same, no, something changed. Something must have changed with an update to Snippets. Snippets is the software used for creating this thing. Even though some of the traces look the same, if you look at the back of this board, there's clearly 2 traces out of this switch. Basically, I don't have the files. I don't actually know what the design file is. Let's touch some connectors. No, actually this, yeah, no. This route exists. Let's touch some connector. What are these errors? I think I must have ordered this with errors. D9, that's the diode. I don't think all these keys are going to work. It's probably going to be a little bit sporadic which ones don't work, because it looks like just randomly, like, this diode. Okay, here's the problem. This diode, in the centermost diode, doesn't have a pad. I did upload it to JLC. So in theory, JLC will have it. But look, this center diode here, it has 2 traces. So something changed. So this board might fully work. Also, having the design files in JLC, like, yes, yeah, this is crazy, huh? Oh, sorry, I'm not showing the camera. I'm like pointing. Yeah, this diode, you can see there's 2 traces on that center diode, but when you go to the program, it doesn't have the 2 traces. So I think this board should actually work, but our auto router is choking in on the latest version for some reason. And I have no idea why it would choke. That's super interesting. Why would it choke on the latest version? Huh. Okay. Well, that is interesting, but yeah, all right. I don't know. Touch some wires. I don't know. The continuity test we have to do, it's this top left pad to... wonder if there's no mobile view here. Connect dots without overlapping. It's basically identically that. So we're trying to find something that this pad connects to. This pad is supposed to connect to a port. Sorry, I think I'm confused because the design file changed. Oh, this guy connects to diode. Okay, this one is supposed to connect to another port. So what port does this connect to? Yeah, okay, there's our continuity test. Okay, all right. I was very confused there. I think I know what we need to do for our continuity test. Okay. Whew. All right, that was I was struggling. I was struggling there. Okay. I'm glad the traces are so visible. Okay. You know what's interesting? This beeper is filtered out of the background noise, so you guys can't hear that beep. I'll just say beep whenever it beeps. I think it's probably not going to beep though. Okay, so that reads 0, which is not good. But if I switch them, we might get 0.6 on the multimeter, which would indicate it's going through a diode. I actually get nothing. That's not good. All right. That's fine. Oh, interesting. Oh, the button wasn't down. Right. You have to press the button. Just need another hand. All right. You know what? Hold on. Let me prop the camera a little bit. This is quality. We do a bit when you talk. Okay, cool. Yeah, I think my noise suppression is killing the beeps. I wonder if I should assemble 1 or 2 of these keyboards today. That's what I'm currently debating. Like, because I have 5 Pico boards right now. So, okay. I'm going to touch this and this, and then I need to also press the button. Wow. If I was in a kitchen, I would shout, hands. That's what you say when you need hands, and I do need a hand right now. All right, let's try this. Let's start by pushing the button. Okay. Yep, it says 0.6. All right, very anticlimactic, but that means it's going through the diode, and that only happens when you press the button. So this button should work, and we probably will literally start by saying, okay, 1 button works. The other interesting thing about this design, this is going to be so hard to figure out without the schematic. We might actually, before I fully do this, we might add snippet downloads at least to this tool so that I can see some kind of version of the schematic. But basically what you do is you literally flash a positive signal on some of these lines. So this top left pad I was doing, which is the positive side, we literally flash it. And then we look at we read the response and we go, okay, when I flash this happens. and then you flash a different one, and you say, okay, when I flash this happens. And through that flashing process, you're able to figure out the grid of buttons. I forget what the technique is called, but it's very common because it's a good ratio of number of pins you use on the microcontroller versus number you need. You don't need 9 pins for 9 buttons. If you use this flashing technique, I think we only use 6 here. But there are some problems with this kind of stuff. So, okay, so I'm gonna run to my lab. I haven't soldered in there before, so and also there's a very San Francisco thing. There's a homeless encampment outside of my lab, so I need to figure out if they will let me in. I think I might have to call someone because I think they locked it down super tight because of the encampment, which is a very interesting problem. I also just started renting this lab, so we'll see how that goes. But yeah, I'm gonna solder on the microcontroller, and then we'll come back and we'll do some programming. But unfortunately, I can't solder on stream. Thanks for tuning in for this part 1. And there's going to be a part 2 to keyboard version 2, where hopefully we get the keyboard to work. So thanks for joining.